In this video, we're going to look at running regressions in Excel. And this is another one of those functions that's made very easy using our data analysis tool pack. And regressions are used commonly in the social sciences and in research more broadly to try and look at the relationship between two variables. And so that's really what I'm going to show you now, is the relationship between a couple variables I've got here. So we've got attendance. So people's students' attendance marked out of 100. So we've got ratio data. We've got their grade and their hours worked. And so these are all numeric, and we can work with these to see how they relate to each other. And so what we're looking for is a correlation coefficient, or in this case an R squared, to see a measure of how the two data points are related. And so there's a couple different ways we can get to that. So the first way is to use the charts function to give us the scatter plot. Now, one thing that, just as a rule, when we are doing regressions, we want our dependent variable, our y variable, to be on the left. So in this case, what I'm going to do is I'm going to copy my grades column over to here. So now I could do this twice. I could do a pairwise comparison, grades and attendance, and then I can do another one, grades with hours worked. And hours worked might be relevant if students have a part-time job. Maybe that's got an impact on their grades. That's what we want to see. So grades are our dependent variable. What does it depend on? Is it a function of your attendance? Is it a function of you having a part-time job? And we can look at both of them. So first thing I want to do is highlight my data set here, and then go to Insert and Recommended Charts. And I want a scatter plot. This is where this is really what regressions are, is sort of looking at the trend line in a scatter plot and looking at the distance, the square of the distance of each point from the trend line. And so that's a mouthful. I'll show you how that looks visually. So this is our trend line. So we can see a upward sloping relationship between our two variables. So as one goes up, the other one does as well. That's really what we're asking in a regression. If we change one variable, does the other variable move in concert with it? And we can add a trend line to our scatter plot here. So if I click on the add button, I can add trend line, and you can see the trend line there. So I'll add that, and I'll go to, so I'll add trend line and also select the additional menu for more options here. More options. One of the things I can get it to do, you can look at different types of trend lines, moving averages, and so on. But I want to see the R squared value. This is what we're looking for when we run a regression, is the R squared value. So here I've got my scatter plot. I've got my line of best fit. And then what the regression equation would do is look at the square difference of these data points from that line. And what that would do is I would come up with an R squared value. And the R squared value tells me how much of the change in grades, my y-axis, is due to changing attendance. So how much of an impact does your attendance have on your grades? And in this case, what that's telling me is 78%. 78% of the variation in your grade can be chalked up to attendance, or at least they move together. So as people attend more classes, their grades seem to go up, and it's about a relationship of 80%. So that's really what we're looking to do. We're looking for that kind of correlation. Easiest way to do it, highlight your data, put it in a scatter plot, and add your trend line with the R squared. You're done. That's everything you want to report. So that's with attendance. So this is a positive correlation. R equals 1 would be a perfect positive correlation. That means we know that 100% of the movement in our dependent variable would be explained by our independent variable. So now we're going to do the same calculation for grades and hours worked to see if there's any relationship here. Insert, recommended chart, scatter plot. And again, we see a cluster that's got a bit of a relationship. It looks like it's somewhat downward sloping. And we don't know if those are related, so what we want to do is stick our trend line in. So add my trend line and add my more options to give me my display r² value. So what we see is a downward sloping line of best fit through my cluster of data points with an r² of 0.55. So what that's telling me is this is a negative relationship for one. So as we change one variable, the other one goes down. So rather than going up together, which is a positive correlation, this is a negative correlation. So as hours worked go up, your grades go down. And what this r² value is telling me, we've got about 55% of the variation in your grades is influenced by the hours that you work in your part-time job. So that's what that's telling us. So that's just a very simple look at a regression. Another way of running a regression is actually using the data analysis tool pack. So if I go on my data tab, click data analysis, and look for regression. It's going to ask me some questions. Okay, what is my input Y range? And again, that's got to be on the left. So my input Y range. So I'll select. All right, input X range. We'll go with attendance this time. Okay, there we go. I've got my labels on my graph. Yes, I do. Confidence level is 95%. Where do I want this? My output range. I'm gonna put it right here, right beside my data sets. And then I click on OK. And it gives me this very messy looking regression table. And there's a few things I'm looking for, really just a couple things I'm looking for, really. And that's my r². My r² tells me 78% of the variation in my dependent variable is caused by the change in the independent variable. And we got that just from our trend line. So that's done for us. The adjusted r² takes into account the sample size. We can see the standard error, which is the standard difference from the mean in units of the dependent variable. So we get, so that's, I mean, we don't really need to know that. The one that we're concerned with is the r². What percentage is this due to? We would also want to know what the p-value was in terms of our significance. So for this intercept, the attendance intercept, I would want to see a p-value of less than 0.05. That's our 95% confidence interval for those of you that have taken stats. I want to see that number less than, so that I know these are statistically significant. I'm only looking at a sample size of about 17 people here, or 18 observations. So I need to know that that is statistically significant. And here we've got a p-value that's very, very, very close to 0. So that means that it is statistically significant. So that means we have a pretty good confidence, a 95% level of confidence that this is an accurate measure of r². And of course we could do the same thing for our hours worked. You would see your r² here, and then you would see your p-value of the significance, and those are the big ones here. So when you're interpreting a regression output, that's one of the first places that you should look for. You should look for to see that r², to see what that relationship is between the two variables.